Okay, let's take a look at this nice bicycle angular velocity problem. So we've got our bicyclist pedaling at 195 RPM. That's how fast the pedals are going around. That's an angular speed. We're going to convert that over into radians per minute. Just a simple conversion. Still an angular speed here for how quickly this chain ring is rotating. Then we're going to find the linear speed of the chain, because the chain is here at this radius at the edge of this circle. So the chain is moving at some linear speed, like feet per second, miles per hour, in this case, inches per minute. Over here, the whole chain is moving at the same linear speed. So we're going to work backwards and use that linear speed of the boundary of this circle to find his angular speed. And then this entire back wheel is all rotating at the same angular speed. We can now find the linear speed of a point here on the boundary. And that'll be how fast the bike's moving. So that's our goal. We're going to start with how quickly the bicyclist is pedaling and convert that into how fast he's moving in miles per hour. So the first thing we have is we know our angular speed is 195 revolutions per minute. We're just going to do what we call dimensional analysis here to convert that to radians per minute. We know 1 revolution is equal to 2 pi radians. So we're going to multiply this by a fraction that's really equal to 1. I want to end up with, over here in my answer, I'm going to have radians per minute. I know that because the answer tells me that. So I need radians to be on top here, and I need revolutions to be on the bottom. See, I want revolutions to cancel out, leaving radians over minutes. Well, we know 1 revolution equals 2 pi radians. See, these two are equal. 1 revolution is equal to 2 pi radians. I'm really multiplying by 1. These are equal. Revolutions cancel out, and I get 195 times 2 pi, which I can do on my calculator here. So I want 195 times 2 times, and then my pi button is right there. 1225.22. That's my angular speed. That's part A. This chain ring is rotating at that rate, 1200 radians per minute. Part B, the linear speed of the chain. Remember, linear speed is given by V equals R omega. R is your distance from the center. So in this case, what's my radius? They tell me the diameter of the chain ring is 12 inches. That's the entire diameter. My radius will be 6 inches. So 6 inches times that omega, which is in radians per minute. Remember, radians are unitless. They don't carry any units at all. So really, we could ignore the radians. We're going to get inches over minutes. Remember, these are all fractions. Inches per minute. So it's just that last answer times 6. So on my calculator here, I can just hit times 6. There we go, 7351.33. And again, radians are unitless. So inches per minute. That was part B. Part C, we're going to do the same thing but backwards. That's how fast the chain is moving. That's making the edge of this sprocket back here, that boundary, move at that linear speed to work backwards and find the angular speed. It's just this formula backwards. Omega is V divided by R. I already know the V. Divided by the radius of that back sprocket. It was an 8-inch diameter. That's the diameter. So the radius would be 4 inches. And our units here, that's inches per minute divided by inches. That would be something per minute. Radians per minute. Remember, radians are unitless. So that last answer divided by 4. 1837.83. And radians per minute. And then part D. That's how quickly this sprocket is rotating in angular speed. This entire wheel is everything on a circle rotates at the same angular speed. So the rim of the wheel, the tire itself, is rotating at that speed. How fast will the boundary be going? Well, now we're back to this formula. My linear speed is V equals R omega. What's the radius of the wheel? That's the diameter, so I'm going to have to cut that in half. So I'm going to have diameter times omega divided by 2. So 27.5 over 2 times that last number. And again, I can just type this in my calculator. So I'm going to take that last number times 27.5 divided by 2. 25,270.19. But what are my units here? Omega was in radians per minute. R was in inches. I'm going to get inches per minute. They don't want inches per minute. They want miles per hour. I mean, we're done. That's my speed. I just got to do some more converting now just to change that over to miles per hour. Okay, so I'm going to write this down here. 25,270.19 inches per minute. I'm going to multiply by a bunch of different fractions to convert inches into miles and minutes into hours. Let's do the minutes first. Remember, every time we're going to be multiplying by 1, and we want to set up our fractions so that our units cancel out. I want minutes to disappear. Since that minute's on the bottom, I need minutes on top here and hours on the bottom. And we know there are 60 minutes in 1 hour. Now minutes will cancel and I'll end up with hours in the bottom, which is what I want. I want miles per hour. Okay, what about inches? Well, I know there are 12 inches in a foot. So I could do 1 foot over 12 inches. I want inches on the bottom, so they'll cancel that inches on the top. And then how many feet in a mile? I know there are 5,280 feet in 1 mile. Remember, I'm multiplying by 1 here. These two are equal. But now look at my units. Feet, top and bottom. They have to be top and bottom to cancel. Inches, top and bottom, cancel. Minutes, top and bottom, cancel. What's left over? Miles over hours. That's what I want. So now I just multiply across the top and across the bottom. So on the top, I'm going to have that number that I just still on my calculator times 60 divided by, and of course times those ones, but that doesn't do anything, divided by these guys. And that one's not going to do anything. But I do need these in parentheses, that entire bottom. 12 times 5280. 23.93 miles per hour. And there's my final answer. Okay, and that's a good place to stop.